This video is going to walk you through the answer key for the Finding Roots practice worksheet. So the first four problems, we need to find the roots. We're going to list the end behavior, and then that's going to help us sketch a little graph. So for number one, we have x plus 2 times x minus 5 times x plus 4. Well, finding the roots when it's in factored form is pretty easy because you just set each one equal to 0, which in this case you'll just end up getting the opposite. So our roots are at -2, +5, and at -4. So I'm going to graph those. And then -4. We're not going to worry about any other points. We just want to get the general shape of the polynomial. So then the end behavior. Well, this is a 1, 2, 3 third degree polynomial because you add up the exponents of the three factors. And then you'd look at your leading coefficient. It looks like when I multiply these all through, it would be a positive. So your end behavior, since it's positive, is up to the right. Odd degree means it'll be going down to the left. And so I don't have any multiplicity in which any of these roots will bounce. They'll just cross, 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 and up. So we just want a general shape of the graph. The next one, we have x minus 3 squared times x plus 6. So the roots are 3, and you either need to write that this is a double root or write it twice. And then that's just to help you remember that it's going to bounce. The polynomial will bounce off the x-axis at 3 and then -6. Okay, and so then once again I have third degree. If I add up my exponents, I have squared and then to the first. And then my leading coefficient once again is also positive, down to the left and up to the right. And then the only thing you need to remember is that you have to bounce at 3. So I'm going to go down to the left, cross, bounce, and up. For number 3, we have x minus 5 times 2x plus 1 times -x plus 4 times -x plus 9 times x plus 4. Zero product property would put my roots at 5. Remember, if I set that second one equal to 0, I'll get -1/2. If I set the third one equal to 0, I'll get x is 9. So remember, because there's a little negative in front. And then -4. 1, 2, 3, 4. -1/2 is right there. 1, 2, 3, 4, 5. 6, 7, 8, and 9. And then with this one, we have fourth degree, if you add up the exponents. And then your leading coefficient, you might think it's a +1. However, in that third factor, there was a -x out in front. So if you multiply all the firsts together, I'd get 2x squared times the -x would give me -2x cubed times the -x would be -2x to the fourth. So this is actually a negative leading coefficient. And since it's fourth degree, it'll go in the same direction, and that'll both be down. None of them you have to worry about bouncing, so they can just cross at each x-intercept. Cross, 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 and down. And then the last one. Well, with this one, it's not in factored form, so I can't immediately see where the roots are, but I will write down the end behavior. I can tell it's a third degree, and then I have a positive leading coefficient, and so then that will be up to the right and then down to the left. So the only thing I need to do is factor it. Well, I can factor an x out. That leaves me with x squared plus x minus 6. And then I got to take it one step further. What multiplies to a -6 and adds to a +1? That would be a +3 and a -2. So then my roots are 0, -3, and 2. None of them have multiplicity that bounces, so then I just have to worry about the end behavior, cross, cross, and up. The bottom 3 on this page are just writing the equation given the roots. You don't have to make a sketch or anything like that. So for number 5, it says write the equation of a quadratic with x-intercepts at 1 and 5. Well, just your factors would be the opposite, so x minus 1 times x minus 5. If I multiply that through, I'll be left with x squared minus 6x plus 5. You can leave it in factored form, or with the nice easy parabolas, you can multiply it through to get it into standard form. For number 6, write the equation for a polynomial with roots at -1, 3, and 7. If I have a root at -1, the factor is x plus 1. If I have a root at 3, x minus 3, and then same thing with 7, x minus 7. This one you can leave in factored form. You don't have to box or FOIL it all the way through. And then the last one on this page, it says write the equation for a polynomial with end behavior up and then down, a double root at 4 and a root at -2. So this tells us that it should be an odd degree polynomial because they're going in opposite directions. And then it also tells us it's going down to the right, so it should be a negative leading coefficient. And then I have a double root and a single root. Well, that gives me a third degree polynomial. So y equals my negative leading coefficient. A double root at 4 would be x minus 4 squared. And then a root at negative 2 would be x plus 2. And you can leave it just like that. And then on the back, we're giving you the graphs, and you have to come up with the equation for them. And so if you can see the roots, they're not listed in 8 and 9, but they are listed in 10 and 11. So here I can see that it's at negative 3, 2, and 4. So then just in factored form, that would be x plus 3, x minus 2, and x minus 4. I don't need to square any of those because it's not bouncing off and it doesn't make a cubic, so I don't need to cube them. And then I can tell that this is a third degree polynomial because it goes up, down, and then up again. So since it changes directions 3 times, it would be a third degree. And then I don't have to worry about the stretch factor. That point right there I think is like 24, and that's exactly what the y-intercept is. So there is no stretch to this graph. In 9, I can see that the x-intercepts are at negative 1 and positive 2. And you notice that both of these roots, it bounces. So that means they have a multiplicity that's even, or it makes that parabola look. And so then that would be squared. So then I get y equals, well, if it's if it's negative 1, it would be x plus 1 squared, and then x minus 2 squared. And then just to check the degree, it goes down, up, down, up. So then 4th degree, and that's exactly what I'd get if I add my exponents. And then the y-intercept is at 4, which is exactly what we'd get if we'd multiply this through. For 10 and 11, we gave you guys the roots, and then for these ones, we're actually also going to have to solve for a stretch factor other than 1. You can tell that they both go down to the right, so we know that our stretch factor is going to be negative, but there's also going to be a value attached to it. So with this one, if I want to figure out how many times it's changing directions, it goes down. So 1, 2, 3, 4, 5. So it looks like it's a 5th degree polynomial. It bounces at negative 3, so that's going to be a factor that's squared. Crosses at negative 1 and bounces at 2. So the 2 on the ends are going to be squared. So we have y equals, I'm going to put an a there, and then I have x plus 3 squared, x plus 1, and x minus 2 squared. And then there's a point on here that it goes through. This is 0, negative 3. So I'm going to plug in negative 3 for y, keep my a there, and then I'm going to plug in 0 for all of my x's. And so negative 3 equals a. Well, this would be 0 plus 3 and then squared, which would be 9. 0 plus 1 is 1. And then 0 minus 2 is a negative 2, but when I square it, I get 4. So then this is negative 3 equals a times 36. I have to divide by 36 to get my a value. So a is negative 1/12. So the final thing is just plugging your stretch factor in. So we get y equals negative 1/12, x plus 3 squared, x plus 1, and x minus 2 squared. So let's move on to the last one. I can tell that I have a root at negative 2 and it crosses there, so I don't have to worry about multiplicity. It has a root at negative 1 and it bounces, so that's to the second. And then if you look at 2, it crosses, but it has kind of a special look to it. It looks like a cubic, and so this is actually going to give us a multiplicity of 3 at this factor. So then I'm going to write y equals, my stretch factor we need to solve for is a, x plus 2, because the root's at negative 2, x plus 1, and then this is where it's going to be squared because it's bounces. And then I have x minus 2, and this is going to be to the 3rd power because it makes a little cubic there. And if I add the exponents, I get 3, 4, 5, 6, and both directions, both ends are going down, so I know it has to be even degree. And so then just to double check the directions, 1, 2, 3, 4, 5, 6. And then the point that's not on here, it's kind of hard for you guys to see. This is 1 and 1.2. And so I apologize I didn't have it on there, but we're going to plug that point in to solve for our stretch factor. So 1.2 is y, a, and then we have 1 plus 2, 1 plus 1 squared, and 1 minus 2 cubed. So this will be 1.2 equals a. This will be 3. 2 squared is 4. And then 1 minus 2 is negative 1. Cubed is negative 1. So 1.2 equals a times negative 12. So I'm going to divide by negative 12. So then a is a negative 0.1 or negative 1/10. And so then our final polynomial would be y equals negative 1/10 times x plus 2, x plus 1 squared, and x minus 2 cubed. And there you have it.